categorical naive Bayes. Categorical naive Bayes is a classifier and it is used when the features in the data are categorical or binary or even ordinal, but they are encoded. This technique does not allow fractions or float, it is not suitable for data that is in the form of that is having fractions or float. So if you do a Google search and type Scikit-learn categorical naive Bayes, you will find that this is the data, this is the class, and these are the hyperparameters. So first we load the data set. Once we load the data set, this data set is related to the task of deciding whether to play tennis or not based on the environment conditions. And the environment conditions are like the outlook, temperature, wind, humidity. These four conditions, they decide whether the person should play tennis or not. In this case, we have a data set called play tennis, which is in the data frame. We read the data. Now once the data is read, these four columns, they are all categorical data. The outlook column, it has overcast, rain and sunny, three options. Then we have temperature, which is cool, hot and mild, again three options, and humidity, which has two options, high and normal, and wind has strong and weak. So these are the options in this data. So these are categorical data and binary, they have to be encoded. We have used the get dummies function here. Once we apply get dummies function, we get the encoded data. That means the categorical features and binary features are encoded using one hot encoding. Okay. So one hot encoding is a standard procedure for encoding. Those who don't remember what it is, in the previous training we have done, but I will give you a recap. Let us say that our data has a feature x which can take value cat, dog and mouse. But since it is non-numeric data, we cannot directly use this for machine learning. We have to convert it into numeric form. So what we do is we create three columns, x cat, x dog and x mouse. Now wherever cat was present, we set the cat as 1 and we put the dog column and mouse column as 0. Wherever dog column is wherever in the column we have dog, we put dog column as 0 and other two columns as dog column as 1 and other two columns as 0. And wherever we have the mouse column, mouse in the column, we use the x mouse column, we set that as 1 and remaining columns are set to 0. That is why earlier we had only 4 columns, but now it has expanded to at least 10 columns. And then play is the variable which is binary, no need to encode the output variable, at least in Scikit-learn. And then once we get our data, we use train test split. Then once we use train test split, we get train test, y train, y test, then we apply standard scalar. Then the two hyperparameters, we get the list from Scikit-learn website. So I will just show you where on Scikit-learn website you can find complement naive Bayes. Okay, so that is I will tell further. And now we have to search for the hyperparameters. So I write Scikit-learn complement naive Bayes, and we come to the Scikit-learn website, complement naive Bayes, switch to stable version. Okay, so here we have the list of hyperparameters, which is alpha, force alpha, fit prior, class prior and norm. So I copy this, I go to ChatGPT, I paste the list of hyperparameters here, and I will have to write a prompt for ChatGPT. So I write for complement naive Bayes, give parameter grid for fine tuning. So Scikit-learn will give me the parameter grid. So here is the parameter grid. We can copy this, go back, and I have used a different parameter grid, but I will write this new parameter grid also here. That option, I will write option to use below grid. Okay, and I am giving here the ChatGPT prompt that I have given. So ChatGPT prompt for parameter tuning I will paste here. So that's it. Then we get the parameter grid. We create an object of the method, we perform grid search. Here we have to write scoring. So scoring I will write F1 because it is binary classification. So scoring is F1 since binary classification. And then we get the best model, we have predict on the test set, and here we have got the accuracy score. But we can also get the other matrices, like I can say calculate and print. I need F1 score, I need precision, I need recall, I need ROC AUC, I need PR AUC, I need confusion matrix, I need classification report. So many things. So one by one we will get that with the help of our function. Here perhaps I will have to write one more line, because ROC curve function, it requires the probability, so that I will have to create a new variable ypred probs, which will come here, and it will work. So that's it. In summary, the steps that we have performed, I will just write the steps as the summary. So first step was data collection. For us, it was already a data set. Then I will write in detail that it can either be download data, or it can be collect data and store as data frame. Data frame is a pandas thing, Python thing for manipulating data. Then pre-processing can be standard scalar. It can also be train, test, split. It can be remove duplicates. It can be remove missing values. It can be remove corrupt values. Feature engineering means creating new features. Model selection is choose complement Naive Bayes, then here we will have grid search, then evaluation and deployment. These are the hello and welcome back. So today we will see the Bernoulli Naive Bayes. In Bernoulli Naive Bayes, all the features need to be binary. That means all the features should have value either 0 or 1. Now if we have categorical or binary features, then we need to do one-hot encoding and convert them into 0-1 binary form. Only then we can process them. So if your data has any numeric features or if your data has a ordinal features, then it is not suitable to use Bernoulli Naive Bayes for the processing. Or if your features are in decimal points, fractions, so those kind of features, better to use the Gaussian Naive Bayes or any other Naive Bayes techniques, but not the Bernoulli Naive Bayes. The information of Bernoulli Naive Bayes you can get by just searching Scikit-learn Bernoulli Naive Bayes. Okay, and you will get the Bernoulli Naive Bayes here. Switch to stable version, and these are the parameter list: force, alpha, fit, prior, binarize, and so on. So this we have our data set which is on play tennis. So the task for this technique is to identify whether it is suitable to play tennis or not. I will write identify if we can play tennis or not based on weather conditions. So the weather conditions are outlook, which can be sunny, rainy, or it can be overcast. Then temperature can be so on, and these are the list of weather conditions. And based on these weather conditions, we have to make the predictions of whether we can play tennis or not. So I will call the weather conditions as X, since these are the features and this is the prediction. So this is the data frame, and first step is to take the data, convert it to one-hot encoding. So one-hot encoding of the features, outlook, temperature, humidity, and wind. So I have already explained one-hot encoding before in the previous training or videos. So one-hot encoding will binarize the features, especially for binary or categorical non-numeric features. To convert it into numeric form, we need the one-hot encoding. Once one-hot encoding is completed, we will split the data, we will apply Scikit-learn, and then we will apply the hyperparameter tuning on Bernoulli Naive Bayes. So for hyperparameter tuning, you can use tools like ChatGPT. Procedure is simple: just copy the parameters here, go to ChatGPT, and just in ChatGPT you can type that please give the hyperparam tuning with grid search for Bernoulli Naive Bayes. Okay, and it will give you the parameter grid for fine tuning. So this is the parameter grid. You can simply copy this code and get the parameter grid. This prompt also I am giving to you for reference. It is a simple prompt, nothing, just one instruction, and I will copy this prompt and paste. Okay, so we will see the next. Okay, so now that we have obtained the grid search, then the next steps, we can take a scoring. We will keep it F1 since it is binary classification. So scoring equal to F1. Then we have I think yes, so scaled value for on train, and even for the test set we will use the scaled value. So fit on the train and test, get the best values, and then predict on the predict using accuracy score. Further we can get the prediction probabilities. Okay, and then calculate, we can say precision, recall, F1, ROC, AUC, PR, AUC, confusion matrix, and classification report. Okay, so these are some test set measures which we will need for printing or testing our model. Okay, so while we can generate this and use this for testing. Let us see why this is not generating the code. Usually with generative AI we don't need to write the code. We can directly use generative AI and complete the task. Sometimes we will have to use Gemini like this and get the code for each of the metrics. We have precision, recall, and classification report. We have got the code, classification report, metrics, all the different measures, and that's it. We will then tested the model. So this was about using grid search and using the Bernoulli Naive Bayes for prediction of this task. Okay. Then there is another form of Naive Bayes. Let us see that in the next video.